when I started my tech career as a cloud support intern, and that was the first time I created my first Ubuntu virtual operating system on AWS. Since then, Ubuntu has been one of my favorite operating systems, not because it has a cool name, because it has extensive user-friendly features and capabilities. And once we blend Ubuntu features with AWS, the capabilities and features of it rise very, very high. So in today's session, we'll be focusing on that part only. So Ubuntu and AWS, how we can design secure, agile, and scalable cloud architectures for modern workload with Ubuntu and AWS. Okay, so this is the first time I'm finding out this, right? I was researching and I found this survey data that says 60% of the cloud workloads are powered by Ubuntu. Either it's Google Cloud or Microsoft Azure or Alibaba Cloud. Like 60% of the cloud workloads when it comes to operating system is carried away by Ubuntu. And the biggest consumer of it is AWS. Now, talking about the agenda, because we have a very little amount of time, so I'll not take much of time. So first, we'll be looking into what AWS well-architected framework is and how we can design the best solutions on Ubuntu with AWS using this framework in the best possible way. We'll have demos if time allows us. I have lots of demos to show you guys, right? Real world demos. I'll have some questions if you guys have, and smiles, those are mandatory, right? Smiles from this side and smile from that side. That's very mandatory thing. And we'll go home with some awesome learnings. So be with me, and then I'll start my session. I'll start with few questions for all of us audience, and if anybody has answers to it, just you guys can raise your hands. How many of us have used or using Ubuntu? Okay. Most of us have. How many of us have been used or using AWS? It can be for learning purpose or learning production, or deploying production workloads or running production and test workloads, anything, right? I can see lots of hands. How many of us have used Ubuntu but on AWS? Okay, awesome. Now, the last question is, how many of us have used Ubuntu on AWS but with following the AWS well-architected framework? Yeah, I can see two hands, and this session is all about that last question. So let's first see what an AWS well-architected framework is. So its name itself describes, right? It's a framework that provides a consistent approach and best practices for designing architectures that supports modern workloads. It has 6 pillars, and by seeing those pillar names also you can see the importance of those pillars, how important those are when it comes to designing modern workloads. The first one is operational excellence. The second one is security. The third one is performance efficiency. The fourth one is reliability. Fifth, cost optimization, because in Nepali market, if you see software companies or customers who are using AWS, they are very, very concerned about cost. पैसा चाहिँ थोरै तिर्ने अनि उनीहरूलाई वर्कलोड अथवा फिचर्सहरू धेरै चाहिरहेको हुन्छ होइन. हाउ टु ह्यान्डल दोज कस्टमर्स होइन. इट प्लेज भेरी इम्पोर्टेन्ट रोल वेन इट कम्स टु कस्ट अप्टिमाइजेसन अन द क्लाउड. अनि धेरैजनाले सुनि पनि रहन्छौँ AWS इज टु कस्टली, राइट? AWS इज टु कस्टली फर स्टार्टअप्स अर मिडल लेभल अफ अर्गनाइजेसन. सो देयर आर concepts and there are pricing models which we can use to lower that cost. We'll see that also in the coming slides. And the last one that AWS has added in few years, it's sustainability. So we talk about green computing. So we'll explore that more on the coming slides. So let's first focus on the operational excellence pillar. Now these well-architected framework pillars applies to all of the workloads. Now it can be Windows, it can be different versions of Linux, or it can be Mac OS, right? But in today's session, we'll be specifically focusing on the Ubuntu workloads, or Ubuntu operating system. Its major principle is to streamline operations and improve processes for Ubuntu workloads on AWS. Now, for example, you have an idea, right? I want to build an application. So you have an idea, now you gather a team, and then there comes a lot of operational tasks. You need monitoring, you need logging, you need steps to deploying it. Now deployment can be automated or manual. There are lots of operational things. There can be troubleshooting ways, right? And how we are going to manage that. And this pillar talks or helps us in that management of operational tasks. The major design principles are you perform operations as code. Now, there are lots of operations, but this pillar states that you automate each and everything, each and every operational thing through code. Because humans, they do mistakes, but when we set that automation script for doing the operational task, we just hit a command and it fires up and performs the task. So you do all the operational tasks as much as possible using code. And you make frequent, small, and reversible changes. Always do that, right? Because making a huge change and then you are deploying it into the production application and then things, blast, and then there is no way to come back, there is no way to figure out where the problem occurred. So make frequent and small changes so that if that changes fail, we can roll back to the previous state and work on that what that issue was. Refine operational procedures frequently. It's not that once you have written or you have find operational procedure and it will work for years and years. You have to keep changing your operational procedures and steps and best practices frequently. Anticipate failure and learn from all the operational failures. And these are all the design principles that operational excellence pillar talks about. Now in AWS, there are multiple services that can help you with operational excellence. The first one is automating Ubuntu updates. Now, how many of us have patched Ubuntu Ubuntu operating systems? I can see one hand. So patching, now patching can be security patching or non-security patching, or it can be application level patching. So patch are available everywhere. The thing is, when you create an Ubuntu operating system in AWS through a service called EC2, which is Elastic Compute Cloud, it's a self-managed server. It's an empty Ubuntu server. Now you can install anything on that. You can make it an email server, you can make it an storage server, you can make it something else, right? So patching the security of that server is your responsibility, the customer's responsibility. Now imagine you have thousands of Ubuntu servers and you need to patch each of those servers. Now doing that manually, getting into each server, setting some sort of commands, it's going to take like months. But using a service in AWS called AWS Systems Manager, you can run the patch into thousands and thousands of servers at once they are available, and with automation, automatically. You set up the maintenance window that at this time, if any patch happens, you install it on these sort of servers. If you have any scripts, for example, you have Ubuntu server and you want to install Apache on that. Now, manually installing that on 1,000 servers is again going to take a lot of time. You get into that, you hit sudo apt install Apache 2 -y. It's going to take time. But with Systems Manager, you create a script, you write the command, you choose which instances you want to install that, hit the command, you save the maintenance window, and then set a time, and at time, it will automatically update that. So it's too easy, right? Safe deployment with blue-green. So anybody have done blue-green deployments? Anybody? So blue-green deployments are especially meant for production workloads, where, for example, version 1 is running, and you have created version 2. Now, you don't want that version 2 to directly push to the production workload. You don't want the traffic, the whole 100% traffic, to go to version 2. So you set 60% of traffic to version 1 and 40% of traffic to version 2 only. That's blue, that's green environment. So that if anything happens, any issue comes with version 2, you can shift 100% traffic to again version 1. And you can do that blue-green deployment very, very easily with a service called AWS Code Deploy. And that is totally automatic. You set things, you go and chill with your family, girlfriends, have coffee, and things happen automatically. Another is infrastructure as code. Anybody have done infrastructure as code? Terraform, OpenTofu. Yeah, I can see 3 hands. Yep. That is also possible with AWS. There is a service called AWS CloudFormation, which is a native service of AWS for infrastructure as code. But AWS supports a lot of. Ubuntu also supports a lot. So you can use Terraform or OpenTofu for infrastructure as code, for creating infrastructure in minutes. Like you write a script to create a Ubuntu server in EC2, you just hit a single command, for example, Terraform apply, and the things that you have written in the script that automatically creates Ubuntu servers into the AWS cloud. Just one command. And then automation and monitoring, which is very important for operational excellence. Again, you can use SSM for that. And then there is CloudWatch, the de facto service when it comes to monitoring and logging on AWS. You can use that for troubleshooting and monitoring and logs and a lot of things. We can use CI/CD pipelines. Anybody have used CI/CD pipelines for production workload deployments? Yeah, I can see good hands. And there is an, again, inbuilt service, the service of AWS, code commit, code build for building and testing, code deploy for deployment to the production environment, or it can be to the stage environment or dev environment. It can be any, right? And there is a code pipeline that can be used to set that whole end-to-end deployment, and that is totally automatic. So in this slide, we have seen a lot of a few of services of AWS, and those all support automation. You just set things and you are ready to go. That's so easy, right? Now I created a demo, a very beautiful demo, but because of time, I'll show you guys at the end if I have time, right? So the demo was just using the systems manager. I would do the automated patching and run some scripts across multiple Ubuntu servers. So that would have been awesome, but let's move ahead. So I have been told that this hall, no, I don't want to tell. Okay, so just want to tell I have a bit of time so that I can show you those awesome demos, right? Very awesome demos I have created, just depicting the real world scenarios. So we can see that at the end of the session, right? Okay, let's the second pillar, the security pillar, the one of the very important pillar when it comes to Ubuntu, when it comes to AWS, because these organizations keep security at very top notch, right? Because if we talk about AWS, it hosts big organization data like Netflix, NASA, right? All of these organizations use AWS, and they also use Ubuntu workloads for their data processing, data storage, and a lot of things. So it's too simple. Security pillars focuses on protecting your Ubuntu workloads with comprehensive security controls. Design principles, oh my God. So security is very important, right? We are talking about how security pillar is important when it comes to designing and architecting modern workloads. So simple funda, protect your Ubuntu workloads with comprehensive security controls. The design principles are very important for this. You implement a strong identity foundation. Now you have a production workload, you have production Ubuntu server, and everybody is like SSHing inside it and installing stuffs. So that is very important to manage the identity, manage the users, to manage the groups, and to what sort of user, what sort of permissions should I attach to them. Now, Ubuntu itself has features of creating users and group and assigning different read-write policies. AWS itself has also something called IAM, from where we can create users, groups, and assign them policies with the principle of least privilege. Now, what least privilege is? You assign the policies to a user that is only needed for him. Now you hired an intern, you created a user, and then you assigned administrator access policy to it. And that guy went ahead, he knew nothing, and then deleted all the production workloads. That's not good, right? So it's very important to implement a strong identity foundation in the organization. Enable traceability. Now traceability doesn't mean that it should be only related with application code, or how application logins have failed. Now, storing all of those logs is important. But it's also important to track security events, security logs, right? So we enable traceability for that also. And apply security at all layers. Now it can be application layer, that is layer 7. It can be network layer, it can be transport layer. So we apply security at every layer for our Ubuntu workloads. We automate the security best practices. Now implementing security is good, but what if we can automate those security policies, security implementation plans, right? Because as a DevOps engineer, my task is see a manual task and just think how we can automate that, right? So the well-architected framework security pillar also talks about that. You protect your data in transit and in rest. That is very important. And then keep people away from data. Now, when people are involved, there is a lot of chaos, right? One happened right away. If we have assigned that to a machine, that would have been, but that's fine. Problems do happen, but the goal is you keep people away from data. How are we going to do that? By managing the policies the best way. To which user should I give access to a production workload? I cannot give administrator access, or write access to each and every team member in my company. I can give to a designated person, or I can automate actions without involving humans in the production workload, right? So we keep people away from the data and prepare for security events. Even the big companies like Netflix, even Amazon gets a lots of attacks every day. So we be ready for security events, and we need to plan for that. We need to implement the solutions accordingly. So the security pillar talks about these design principles. Now, when it comes to AWS for protecting Ubuntu workloads, the first one comes is network and application security. Now, AWS have multiple security related services. The first one is AWS WAF, Web Application Firewall, that can be used to protect application layer of workloads. AWS Shield is a dedicated service of AWS that protects your workload against DDoS attacks. So it's a dedicated service for protecting your workload against DDoS attacks only. Another one is security groups. Those are firewalls that sit at the server level. NACLs, network access control lists, sit at the subnet level, and Ubuntu has its built-in UFW firewall for layer. So you can combine all of these security solutions and create a layered defense. So first one comes WAF, then AWS Shield, then security group, then NACL, so that any request that is penetrating towards my workload, if it's not valid, it gets cut off at the right away, at the right location, right, at the first step. And only the valid request get into the origin server of Ubuntu. Another one is identity and access management. We talked a bit about that, how we can manage users and what sort of permissions do we need to give to them, right? And one interesting thing about IAM in AWS is IAM roles. So what we can do is, I have an Ubuntu server, right? Now that Ubuntu server wants to push some images to a S3 bucket. What I can do is I can assign a role to EC2 that that Ubuntu server has the permission to push images to the S3 bucket. Only push, not delete, not create, only push. So what we are doing is we are assigning the role to a machine and allowing that machine to do the work of putting that images to the S3 bucket. No humans involved, right? So we can do that also. Threat detection, very important. Lots of threat happens always, right? And there is a dedicated service for that again called AWS Guard Duty. Using that, you can detect threats in real time. I have a demo also regarding that. So if time allows, I can show you guys how threats are detected in real time. So I'll act as an attacker. I'll penetrate some attacks in my Ubuntu server, and it will in real time identify those threats. Data encryption is very important. Now, AWS provides us a default key for encrypting our data at rest. But if I or my organization compliance doesn't allow that, I can go ahead and create my own keys and import that into AWS and then use it to encrypt the data. There is a service called AWS KMS, Key Management System, very extensive service. And there is called AWS Certificate Manager for managing your SSL and TLS certificate that is required for data protection in transit. And other comprehensive security tools, you can leverage AWS Inspector. As its name suggests, it acts as an inspector protecting malicious activities inside Ubuntu workloads. Amazon Macie, Detective, Network Firewall, Secrets Manager for storing your environment variables and other secrets. AWS Config for a complete protection. So these are only a few services. AWS has very extensive services. And it's not that you have to use all of those AWS services, right? You find what's perfect for your workload, and you go ahead and explore that, and then start using on your Ubuntu workload. So it's very cool demo, right? It's, I think, 5 minutes demo. You simulate, what I did was I created two Ubuntu servers. One I acted as a victim server, one I acted as a threat, attacker server. And from attacker server, I pushed some sort of scripts, and then that simulated an attack to the victim server and enabled guard duty, and guard duty very intelligently in real time, in no time, detected that this server is trying to attack this server and provides a lot of information. I can show you that at the end of the session, right? It's very cool demo. The third one is reliability. Now, you are building an e-commerce site, you have implemented operational excellence, you have implemented security, good. But if your workload is not reliable, then implementing security and operational excellence is of no work. So reliability simply means you ensure your Ubuntu workloads can recover from failures and meet demand. Now, design principle include automatically recover from failure. Now, you should design a system or Ubuntu workload in such a way that it can automatically recover from failure. Test recovery procedures, scale horizontally to increase aggregated workload availability. Now, you have an e-commerce site running on Ubuntu workload, right? The first month, there were 1,000 customers per second hitting your website. Now, in 1 month, your website got a lot of crazy fans, I can say, right? And in the second month, previously it was 1,000 requests per second. Now it's 1 million requests per second. Now, my system should be designed in such a way that it can handle 1,000 requests per second also and 1 million requests per second also. So we need to design that reliable workload. So that talks about that. So that and we can do that in AWS very easily. I'll talk a bit later, right? And stop guessing capacity. Now, when you create AWS resources on AWS, you can define processors. Do you need a Graviton processor? Do you need NVIDIA GPUs? Each and everything. And you can define the specifications also. I need, for my Ubuntu workload, I need 4 core of CPU and 8 GB RAM. Or I need 8 core of CPU and 16 GB of RAM, right? You can define that hardware specification. Now, when the load comes high, now you don't have time to stop guessing, like guessing capacity. Like 1 month ago, 2 core CPU and 4 GB was working perfectly. Now the request has come very high. So I think we can increase that 2 core CPU and 4 GB RAM to maybe 4 core CPU and 16 GB RAM. But that's a manual task, and we call it vertical scaling. But in AWS, we can do that automatically using a service called auto scaling. Right? We'll talk a bit about that in the coming slides. And you manage change through automations. Like automation is everywhere, right? Everybody should, because that's a learning opportunity also. You find a manual work and you think in your mind, how can I automate that thing? Because there are always ways of automating things. So that's one takeaway you guys can take. You see in your organization that this task is done manually and it consumes like 30 minutes. Maybe I can write a Python script. Maybe I can write a Terraform script to automate that and help my developers or help my colleagues to do that 30 minutes of task in 5 minutes. So data resiliency, reliability comes with data resiliency. You have a production workload, and after 3 days, that production workload was hacked and deleted, right? The Ubuntu workload was deleted. Now what? You don't have anything. The first thing you can do is you can back up your data, right? You back up your data. Now the backup can be daily backups or hourly backups, right? Or minute-based backups, so that anything happens to my production workload, I at least have a backup in place using which I can roll back to the production environment, maybe in 30 minutes or maybe in 1 hour. So backing data is very important for reliability. And AWS has a very awesome service called AWS Backup, using which you can automatically back up your Ubuntu workloads. Just define which Ubuntu servers you want to back up, define a maintenance window, daily backup. I need a daily backup from that should start at night 12, and you leave it. And every day that backups automatically happens. You don't have to worry about that. You can keep a retention period that after 7 days that backup should be deleted. So it's very awesome service. Even Ubuntu provides you long-term support, right? The free version of Ubuntu provides you 5 years of maintenance and support, whereas Ubuntu Pro provides you 10 years of support and maintenance. So you guys are good to use Ubuntu operating systems. High availability. Now this is a very awesome concept. Now, for example, I have 2 chocolates, right? So I have 2 chocolates, one lost, I have 1 chocolate. I only have 1 chocolate that is lost or stolen, I have nothing. So high availability is that simple concept. Always have 2 things, primary and secondary. Never have a primary, because once anything happens to the primary, you have nothing. So always have that high availability concept. Primary, if anything happens to primary, I have a secondary in backup so that my customers are not impacted. And for high availability, you can combine AWS Route 53. That is a very, very advanced DNS system provided by AWS. You can do failover routing. So you have a primary server, you have a secondary server. It's a service that is strong that it automatically identifies that if anything happens to the primary server, it automatically senses that primary is down. Now I need to send the traffic, 100% traffic, to the secondary region or secondary availability zone. It's that strong, and that shift happens between like less than a minute. Isn't that cool? I have a demo regarding that also. And the health checks and failure, again, I previously talked health check. We can do the health checks to identify that anything bad is happening in the primary and detect that and shift the traffic to the secondary. Scalability is very important. I have 1,000 requests coming per second. In the next minute, I have 1 million requests coming per minute. Will my system able to handle that? And we can do that using AWS service called auto scaling. And that is also automated. We have a minimum, we'll define a minimum server, for example, 2. I need a minimum server 2, maximum 10, and in between I will define a condition that if both of those 2 servers that are currently running has a CPU utilization more than 80%, then increase the server numbers. It will automatically sense that if the CPU utilization or RAM utilization of those 2 servers get more than 80%, it will automatically sense that and increase the number of servers. And that is in tech world called horizontal scaling. And that again happens automatically. You set up a minimum number, you set up a maximum number, you define a condition, and you leave it. You go and chill, everything happens automatically. Fault tolerance. Now you can deploy Ubuntu across multiple regions, multiple availability zones to withstand component failures. Now, if we talk about AWS, AWS has different regions, right? One is North Virginia, one is India, right? And all of those regions has availability zones. Now, those availability zones are nothing but data centers. So one region has minimum of 2 availability zones. Now, anybody can say why there is 2 availability zones designed by AWS in every region? Because of that high availability concept. So, one availability zone, another availability zone. Now you have a very critical workload, and you define 2 servers, one in one availability zone in one data center and another in another data center, so that anything happens, and it can be natural calamities, right? Earthquake, flood, but the chances are very low because AWS takes care of their data centers very, very extensively. But there might be chances, right? The companies like Netflix do that for them. They have production workloads that are residing in multiple regions. So in any condition, if AWS data centers get some sort of attacks or some sort of earthquake or some sort of fire problems, then their data always is in secondary region also for that reliability purpose. And that can be costly, right? You have production, one server running in one region, and another one, you are paying $50 for this server, you have to pay $50 for that server also. So that is costly, but in the cost optimization section, we'll look how we can reduce that more effectively. So in the reliability pillar, what I have done is, I have created a primary server, a secondary server, and there is a cute penguin picture displaying in the website. And then I'm simulating a failure, an intentional failure in the primary, and within minutes it shifts the traffic to the secondary server. If time allows, we can see this demo also. Now the fourth is performance efficiency pillar. Now again, I'll iterate. We have an e-commerce site. We have implemented operational excellence. We have implemented security. We have implemented reliability. But we have not implemented performance efficiency. Now imagine you have an e-commerce site and there is also a competitor. Now your single page of your e-commerce site opens in 30 seconds and your competitor single page opens in 5 seconds. You are going to lose a lots of customers, right? Because in today's world, nobody waits for like 30 minutes scrolling a page, right? So that performance efficiency is very important when it comes to designing a Ubuntu workload. So the first thing what you can do is, for enhancing the performance efficiency, is democratize advanced technologies. Now in today's world, you can see a lots of advanced processors and chips being created. Even AWS itself creates its own hardware, own processors, own chips. Few names are Graviton, Inferentia, Trinium or something. I'm just having bad with that pronunciation, but there are very advanced chips and processors that are created by AWS itself so that they can help customers run Ubuntu workloads on those processors. So it's always good to use advanced technologies, right? Don't follow back with that old Intel chips and things. So if there is an advanced chip available, you find out the cost of that and you run your workloads on that. Because we have to cope with time, because if we are backwards, then the tech world is changing very rapidly, so we need to use advanced technologies for our workloads too. And go global in minutes. If with performance efficiency, we can go global in minutes. So my competitor's single page is opening in 5 seconds. What I can do to open that page in 2 seconds? And then the customer will open, okay, it's too fast. He will recommend that to another friend, or he will recommend to another friend, and that chain comes, and then your application or workloads goes global in minutes. So performance efficiency of your workloads, applications are very, very important. And use serverless architecture. Now this is a AWS thing. Serverless architecture means there is no servers to manage for the end users, although there is some sort of server in the background in the data center running, but there is no servers for the customer to run. For example, if you create a Ubuntu server in EC2, the security, the firewall is your responsibility. Updating that Ubuntu server is your responsibility. Patching is your responsibility, right? That's all your responsibility if you create Ubuntu server on EC2. But if you use Ubuntu server on Elastic Beanstalk, that's a very effective service, platform as a service provided by AWS. You can run Ubuntu workloads on that also, but it's a serverless service. So you don't have to manage anything. You don't have to manage patching. You don't have to manage security. You don't have to manage other things related with operating system. That is totally managed by AWS. So you can go ahead and use serverless architectures also for your workload. And experiment more often. That performance doesn't mean I achieved that 3 seconds for opening one page. Now that doesn't mean I'm cool, right? My competitor might be working too hard to get that to a 1 second. So you always experiment things, how you can make your workloads more performance efficient. It's an ongoing process. So you experiment things more often to find how you can fine tune your workloads. And consider mechanical sympathy. That's a very important thing, very critical thing. I'll give an example of that point. So when I was in class 8, my friend's father has a bike. It was a Passion Pro, very old model, right? And I was very passionate about riding bikes. I didn't know nothing about bikes. I got the key, put the kick, and shifted with one gear, and then revved that, right? And I think in one gear, I rode that bike for like 20 minutes. And it got too heated, and it just collapsed. But now I own a 400cc bike. I know very much about that bike. I know when to throttle, when to shift gears, what should be speed when I am revolving, when I'm doing sharp turns, right? I know a lot about that. So this last thing, consider mechanical sympathy, talks about you need to also know about the hardware, the software, how those hardwares are built. For example, let's take example of Ubuntu operating system. There are various inbuilt features. There is kernels involved, there are threads, there are processes. So if you understand more about that hardware and software thing involved inside a machine, you can build that performance efficiency thing more better way, right? So the more you know about something, the more you have an idea on how you can fine tune that thing. So at class, I was revving my bike. I didn't know how that gear thing worked. I just only knew that एक gear लगाउने, and then you rev that and bike just goes. And that was a bit fun, but I got too much scolded by my father because the bike just got shut down. So it's very good to consider mechanical sympathy also to learn about the hardware. It's not that Ubuntu is there, let's run workloads. It's also important to understand its major components, the kernels, the threads, the processes, how things work. That can also help in performance efficiency. And now if we talk about how we can enhance performance efficiency on AWS, the first one is content delivery and monitoring. Now, content delivery is very important. Now, simply content delivery means that I have a server in Mumbai region or in Nepal, and the users are from USA and Europe, and few users are in Nepal also. So the Nepal users will have less latency because the data center or the workload is hosted in Nepal only, right? But the user that is accessing the same application from USA or Europe, the latency is going to be a bit high because of that length. But what I can do what I can do is how I can fine tune my application that a user from USA also accesses my application in 5 seconds, and a Nepal based user also accesses my application in 5 seconds. How is that possible, right? How we can decrease that latency? We can decrease that using a concept called content delivery network. That simply means you case the data in multiple locations. So a user in USA don't have to reach to the data center or Ubuntu workload that is hosted in Nepal. It will find somewhere near edge locations. There are edge locations that is the data is cached there, and if they hit the same content, they are going to hit that near edge location, the data where the location where the data is cached, and they will get it, and the response time will be less. And there is a service in AWS called CloudFront, which is a dedicated service for content delivery network. And it very effectively uses performance efficiency. Banks like in Nepal, Nabil Bank and other banks use this CDN, CloudFront, for their performance efficiency. Another one is monitoring performance. Now you have a workload, and how are we going to identify that it's working perfectly, it's performing perfectly, right? So monitoring is also very important. Previously I told CloudWatch is the service that is the core service of AWS when it comes to monitoring, right? Okay, so we can use that. We have CloudTrail, we have X-Ray that provides us very in-depth performance analysis. We can use optimized hardware, right? AWS builds its own chips. There are NVIDIA chips. And the best part is on AWS, when you are choosing an Ubuntu operating system, you can run your Ubuntu operating system on all of these processors and chips. If you have ML workloads, if you have generative AI workloads, if you have something related with security workloads, there are processors that are built for that purpose only. If you have a workload that is compute intensive, that consumes more CPU, if you have a workload that consumes more RAM than CPU, so there is servers or processors that are more capable of handling or providing that memory optimized solution for you. So there are multiple options that AWS provides, the optimized hardware, and based on your requirement, you can use one. Again, that's optimized AMIs. AMIs are just images, like Ubuntu has its own image, right, using which we can create it. So AWS has its own optimized AMIs for a lot of things. ML acceleration again. For ML workloads, you can use Ubuntu with AWS Inferentia, Tritanium chips, and NVIDIA GPUs also. The performance efficiency pillar demo is also the cool one. So what I did was I created a demo for each of us, for each of the pillars, but at the end we will see few of those. Now we are at the 5th pillar, and then there's 6th, and then maybe we can see a cool demo, right? The 6th one is cost optimization. So I'm currently taking the example of an e-commerce site. We have an e-commerce site. We implemented security, operational excellence, reliability, and performance efficiency also. And now at the end of the month, the AWS bill came, right? The company expected that the bill would be around $100, but the bill was $1,000. Now there will be questions how that bill came, right? That's the very common thing when it comes to running Ubuntu workloads on AWS or other workloads on AWS. I heard a lot of people saying that AWS is very expensive. So cost optimization pillar talks about optimizing cost while maintaining business value with Ubuntu on AWS. Let's see its design principle. The first is implement cloud financial management. You teach your team or you teach your finance team how cloud pricing works. So for example, you have an e-commerce site, there are 5 developers who are working on that. They each need to know how AWS cloud billing works, how the pricing of those resources work. Until and unless they don't know about that cost, they are going to randomly create servers, and then at the end, they will get a lot of bills. Second is adopt a consumption model. AWS has a lot of consumption models. The first is reserved instances. You can reserve an instance for long-term use. It can be one year reservation or 3-year reservation. And the real world thing is, if you reserve thing for a longer period of time, you get a discount, right? And that happens to AWS also. So if you reserve a processor or an instance type for a longer period of time, AWS offers you a specific discount. And there is savings plan, there is spot instances. These all are the consumption models that you can use to save cost. Now the thing is, a consumption model or pricing model might not work for you. For example, if you choose spot instances, you can save 90% of your cost. Means $1,000, you can save $900 using the spot instances. But the thing is, spot instances are not made for production workloads. They are made for especially testing purpose and storing data or doing some batch processing jobs, because they are very critical, right? So you need, or your team needs to be very skeptical when it comes to choosing a consumption model. And stop spending money on undifferentiated heavy lifting. And the best example of that is cloud. You don't have to go and bring servers from the market and set up your own data center. You don't have to do that undifferentiated heavy lifting. AWS is there for you, right? You go there, you create 10 Ubuntu EC2 instances, and then at the end of the month, you pay for what you have used, right? And that's why the cost optimization pillar talks about that also. You stop spending money on physical hardwares and come to cloud and run your workloads accordingly. And analyze and attribute expenditure. Now, the cost can increase anytime. So you or your team also need to be very skeptical when it comes to analyzing cost, the monthly cost. So this month cost was $100, previous month cost was $110, or the coming month cost was maybe $200. Now why there is $200, guys? We need to figure out why, from where that $200 came. We need to get that cost released, right? Get that cost less. So we need to analyze and attribute the cost expenditures also. And for cost optimization, the techniques are right sizing and efficiency. Now, as a DevOps engineer, someone came to me, hey, I need a Ubuntu workload on AWS. And I said, okay, let's do that. And then I went ahead and created, and instead of choosing 2-core CPU and 4 GB RAM, I mistakenly chose 16-core CPU and 86 GB RAM. Now you can see how much of billing that guy is going to get at the end of the month, right? So right sizing the instances based on requirement is very important. Now the question is, someone told me, okay, I need an Ubuntu instance. Now it's my responsibility to understand their requirement and then suggest them a right size for their Ubuntu server. But what if we can automate that? And there is also a AWS service called AWS Compute Optimizer that helps you in that recommendation. So it automatically shows you that, okay, this is your workload. Previous month you were running this instance type with 4-core CPU and 16 GB RAM, and it's underutilized. It's not have been utilized properly for 2 months. And it provides you a guidance that, okay, from the next month you can use this instance type and save this much amount of cost. So you can use compute optimizer for that purpose also, for optimizing and right sizing the cost. And you automate the cost control. Now AWS has a lots of feature when it comes to cost controlling. Two of them are very important. AWS budget, where you can define that if this threshold of budget is crossed in my AWS account, send me a SMS, send me a notification. If $100 crosses, then send me a notification that your threshold has been breached, and I can go into my AWS account and talk with my team and then sort that thing out. Another important thing when it comes to automated cost control is cost anomaly. Now, the first month your billing was $100. The next month your billing was $2,000. So there is an anomaly, right? There is some sort of anomaly that triggered that big amount. So if we set up a cost anomaly detection, that cost anomaly will at the first hand identify that, okay, so it in the background it uses a lot of machine learning and things so that it analyzes my previous cost, and then if there is any sort of cost anomaly detected, it automatically sends me a SMS or email notification that, hey, your previous month was cost was this much, but it's increasing very rapidly. Go and see your AWS account, what's happening. So we can use AWS budget and AWS cost anomaly for that. And that's totally free to use, right? The cost optimization features like budget and cost anomaly, they are totally free to use. Another thing is granular cost monitoring. Now I got $1,000 at the end of my month, but from where that cost came, I need that whole structure. This service ran for this hour, that's why this cost this much. I need that granularity, right? So that I can present it to the finance team and they can look, okay, this is valid, and they can see of that cost to the AWS. So for that granular level of cost analysis, there is a service called Cost Explorer that is also a free service that you can use for very granular cost analysis. And the last one is flexible purchasing option that I talked previously. Reserve instances, spot instances, savings plans, anything that fits your workload, you can go ahead and use those. And the cost optimization, I just in the demo showed some overview of Cost Explorer and how AWS budget and cost anomaly works, because I have set up that in my AWS account, right? I don't want surprise bills on my end, because I don't have a credit card, international credit card to pay to AWS. And there was an overview of AWS Compute Optimizer. Now let's move to the, last pillar of our well-architected framework. Now I have a question. Now, from us, how many of us love Earth? Earth? Any lovers of Earth? Earth? Yeah. So I cannot see. So everybody loves Earth, right? It's a very beautiful place. It has hills, it has mountain, it has rivers, it has wild animals, birds, right? And that's the only place where we find ourselves, right? So it's very important. The Earth is very important. We love Earth. All of us love that. So the well-architected framework of AWS, this well-architected framework, the sustainability pillar, so it was not previously added by AWS. So it's been like few years, AWS has added this pillar. So this pillar talks about green computing. Now, I have an AWS account. I can create 1,000 Ubuntu servers or maybe 1 million Ubuntu servers. But in the background, those servers are created somewhere in the data center, right? And a data center for running server needs electricity. There is a lot of power consumption. Those servers run 24/7. They need cooling systems, and those cooling systems again need electricity and fuel and a lot of things. And a lot of that processing generates carbon. There is a carbon emission that is just degrading our earth, right? And AWS is very serious about sustainability. So AWS has a goal that their all data centers will have net zero emission of carbon by 2040. And they have started that work already. Most of the workloads run on renewable energies. They use water for server coolings. They use solar powers instead of electricity or fuel consumption for lighting up or operating their data centers. So they are already using renewable energy for that. And by saying that, we can say that, okay, AWS is doing that, and by using AWS or Ubuntu on AWS, I'm also contributing in the green computing, because AWS always supports renewable energy for running their data centers. So minimize environmental impacts of running Ubuntu workloads on AWS. You understand the impact. I created 1,000 servers, I forgot, right? I need to have that mentality that, okay, creating 1,000 servers may increase or may raise this amount of carbon emission. And I need to figure out how AWS is managing that. How is that going to impact the environment? We need to have that understanding of the impact, right? And establish sustainability goals. You are a small organization, you are a big organization, you need to have that sustainability goal into your company, right? Because otherwise, I love Earth is just going to be just words, right? So, and you provide maximum utilization. It's similar to you have food, you have eaten half food and you have thrown half food. That's not good, right? That's similar with AWS itself. So you have a server, you utilize it to the maximum. So you have a workload, e-commerce workload, and it might work on like 2-core CPU and 4 GB RAM, but you have used 8-core CPU and 16 GB RAM. That's not needed, right? The more resources you use, the more higher amount of servers are created in the data centers that might impact the environment. Anticipate and adopt new, more efficient hardware and software offerings, because AWS builds its own processors, and those processors run on totally renewable energy. The best example is AWS Graviton 4 processors. Those run 60% on the renewable energy. So always prefer using those processors, those chips, those support sustainability. And use managed services. Managed services means the services that AWS manages. The customer don't have to manage. You simply go and use it. AWS does the patching, the security, and everything for you. And AWS itself takes care of the sustainability behind that services. And reduce the downstream impact of your cloud workloads. And the best quote I found on the internet, the greenest energy is the energy we don't use, right? It was stated by Peter DeSantis at AWS reInvent 2020. So for sustainability pillar implementation, you can do resource optimization. You can use AWS Compute Optimizer so that you can run only the servers that's needed for my workload. Efficient workloads, you can use processors like AWS Graviton that consumes optimal energy efficiency. You can use sustainable storage. So if you have a file that is 2 TB, right? And you don't, on a daily basis, you don't access that file. Then you can send that file to a deep archive. And by that way, you can help reduce storage footprint. And sustainability pillar, the cool thing is you can also track how much of carbon emission you have emitted in the last year through a service in AWS called Carbon Footprint Dashboard. And through that dashboard, it shows you that you have run this servers, this services in AWS, and you have impacted this much on the environment. So you can track your carbon emission also through the AWS console. And again, the greenest energy is the energy we don't use, right? And for the sustainability pillar demo, it was just overview of AWS Carbon Footprint tool. Now, the conclusion is we use AWS well-architected framework because it provides us the comprehensive and best practices so that we can build, design resilient, performance efficient, cost optimized, and sustainable workloads on the cloud. The next step, you go and start learning and building about AWS and Ubuntu the best way possible, that is using AWS well-architected framework. Thank you. Yeah, if you guys are interested, maybe we can see a demo. Anybody interested? Okay, awesome.
So do you see any case where owning the private server is more beneficial in terms of cost than using the AWS service?
Yeah, yeah, yeah. Yeah, so as per my experience, regarding the Nepali market, I haven't seen that much difference because there are multiple customers in Nepal, like startups, right, who still use AWS. And the best part is there are companies in AWS, like I'll not take the names, but there are companies in AWS who can help those startups implement these pillars the best way they can optimize the cost, right? But it totally depends on the customer on which cloud platform they want to switch. I have seen customers leave the company, leave AWS because of cost case, and they opt with other cloud providers. Like I have seen few customers use Oracle Cloud, Hawaii Cloud, right? Because they provide cheaper amount of price for the server. So it totally depends on the customers. But yeah, I have seen customers who leave the AWS account or AWS because of the cost. There are customers, yeah.
Thank you.
Thank you. Anybody? Any other questions? Yeah.
In AWS, you named everything around Ubuntu, right?
Right.
But generally, everything that you mentioned is better performant in Amazon Linux. So what would your say on that? My question is, shouldn't I just go to Amazon Linux because all of those things can be done better on with better performance?
Okay, so now it's again the customer's choice, right? Ubuntu has a lot of features that Amazon Linux might not have, and Amazon Linux might have some features that Ubuntu might not have, right? So it's totally depends on the customer's choice that which operating system they are going to use, right? So when any customer comes to me and they ask, right, what operating system should I use for my workloads? So as a solution architect, as a DevOps engineer, I totally ask them, it's your choice. These are the capabilities that Amazon Linux can perform. These are the capabilities that Ubuntu can perform. And then they make that choice by their own. But it doesn't mean that these pillars that I have told you guys, if we implement that on Amazon Linux, it's going to provide more effective results than implementing those pillars on the Ubuntu workloads. That's not correct, I would say, because both of those provide the same performance. But at the capability level, at the feature level, there might be some difference. So it totally depends on the customer what they need. Did I answer your question? Yeah, thank you. Any questions? Any more questions?
One question.
Yeah.
Question. So are there any policy restrictions that does not allow like data of Nepali people to be stored outside of Nepal boundary?
Okay, so I do.
Or in addition to that, like, is that being a bottleneck for companies who try to use AWS or who is willing to use AWS services?
Can you repeat that question?
Yeah,
so
so
that
first question is like, are there any policy restrictions in Nepal that does not allow data of Nepali people to be stored outside of Nepal boundary? If there is, then is that being a bottleneck for companies who is willing to use AWS services?
Okay, that's very nice question. I do have experience with that, right? Because I have worked with multiple banks, Nepali banks, right? And in Nepal, there is a policy that the customer's data should not be residing outside Nepal, right? And as AWS has no data centers in Nepal, the nearest data center that AWS has is India and Singapore, right? So because of that, yes, the bank's data, the government data cannot be hosted on the AWS as per my previous knowledge, right? I don't know if those policies have changed now, but previously that was the thing. And that created a lot of bottlenecks for government companies or banking sectors to host their applications on AWS. But the best part is the non-critical applications like banking websites, right? The applications for sending emails, OTPs to customers, those sort of applications that doesn't store the customer data in the cloud, just do the processing, those sort of website can be hosted on the AWS. And there are multiple customers like Muktinath Bank and others, those are like using AWS for those common things. Yeah, thank you. Oh my God, demo is ready. Okay. There are lots of demos, maybe. So there is only one demo for reliability. Okay, so let's see this one only. So currently I am in one region called Ohio, and there is a, maybe can we start from the beginning? I was just accessory. So let's see this demo and then we can wrap up. This is a cool demo. So this is from the beginning, right? Okay. So this is the dashboard of the AWS account, right? And I have created one Ubuntu server. I have named it primary server, and it's hosted in Ohio region. And then there is a secondary server, Ubuntu server, that is hosted in Mumbai region. So my primary is in one region, the secondary is in Mumbai region. So there is a huge difference where the data is stored. Now I will go to Route 53, which is a DNS management service, and I will create a failover routing over here. I have already created UbuCon Asia 2025.1 Cloud Helper, primary server, and then there is a secondary server. And I have pointed the A record as a public IP of those primary and secondary servers, right? So same domain name, but there are multiple IPs or two IPs, primary IP and secondary IP for that. So this setup is done. We are good on this part. The second is health checks. How it is going to identify that primary server is down. For that, we need to set up health checks. I have already set up that. So if I go inside that, currently it's showing current status is healthy because the primary is healthy for now. So URL, it will sense that if this IP goes down on port 80, it will automatically sense that the production site is down, and it will shift the traffic to secondary server. So, and I have a search string matching also. So awesome, if the word awesome is not found on the primary server, it will automatically detect that the primary server is down. So awesome is a simple HTML word I have printed on the web application, and you can see currently it's healthy. So what we can do is we can use DNS checker, right? Use the domain name and search for area code. And currently it's showing me the IP address of the primary server, right? That is the primary server 18.191. You can see, you can verify that in the details. This is the primary server public IP. So currently the domain is pointing to that one. So we'll simply hit the domain UbuCon Asia 2025 One Cloud Helper, and it says everything is awesome. That is the one word that I have triggered, that if that word awesome is not found, you treat that the primary server is down, right? There are like my favorite penguins from Madagascar. And now we will intentionally create or introduce a failure in the primary server, right? What we'll do is I'll simply stop the Apache web server that is responsible for running our web application. Currently it's running. I'll simply stop it. So it's an intentional failover or failure. So currently the Apache is stopped, right? Now if I go to Route 53 health checks and refresh it, immediately it's going to tell me that there is connection refused. Now Route 53 comes in place and says, okay, the primary is down. Now my responsibility is to shift any traffic that is coming to UbuCon 2025.1 cloudhelper.com should be shifted to the secondary region, that is the server with the IP 15 point something. So now I can choose search for the same domain name, and you can see the IP address has shifted to the secondary region 15.206 and 174.243, right? And this is the IP of my secondary server, and that happened automatically. Now if I go and refresh my page, right? It says, oops, primary is on a coffee break, but don't worry, secondary server is here pulling all-nighters. You are on a secondary server. You didn't see anything happening in the background, right? You refresh the page and you were redirected to the secondary server. And that's the beauty of how AWS helps customers to run any workload, especially the Ubuntu workloads on the AWS cloud. And again, I will start. And the best part is you start the primary server and automatically detect that, okay, primary is up. Now I need to shift secondary traffic from secondary server to primary. And that happens automatically. So I have started my primary server, and you can see it has already sensed it that the server is healthy. Now I can go to DNS checker. I will refresh the IP. It will again map through the primary server only. You can see it, the IP of primary server came. And if I refresh the same domain, it will reflect me back to the primary server. UbuCon Asia 2025.1cloudhelper.com. And the primary is up again, right? Nobody knows nothing what happened in the background, and the switch from primary to secondary happened in no time. So that was a demo on reliability pillar. So hope you guys liked that. Hope you guys enjoyed the session of mine, and thank you once again.